In this video, we're going to talk about the nomenclature of carboxylic acids. So you've seen this table many times before. This is the list of our functional group priorities. And carboxylic acids come at the very top. So we're not going to encounter any compounds where something has a higher priority than a carboxylic acid. So it will always be named as the base group. Some of these other compounds that we haven't talked about yet, we're actually going to get to in this chapter. So later in this chapter, we'll talk about esters, acid halides, amides, and nitriles. Alright, so in the nomenclature of carboxylic acids, we change the suffix to oic acid. So normally this would be butane. When we add the carboxylic acid group, it becomes butanoic acid. In this case, the alcohol gets less priority than the alcohol, so it's named as a substituent. And we have 1, 2, 3, 4, 5 carbons. Putting the groups in alphabetical order, we have 5-hydroxy, 4,4-dimethyl pentanoic acid. And if you notice, because the carboxylic acid, by definition, has to be on the end of the compound, and it always gets the highest priority, it is always going to be at position 1. And so we don't generally give the locant because it's understood. In this example, we have a cyclic alkane with a carboxylic acid coming directly off. And this is analogous to the same situation we had when we had a cyclic alkane with an aldehyde coming off. In this case, the molecule would be cyclohexane carboxylic acid. There are many common names for carboxylic acids. I think it's important that you know acetic acid. You've encountered this many times in your chemistry career. You'll encounter it many times since. So I will expect you to know acetic acid. We've already encountered benzoic acid. You need to know that. The other ones, I'm not going to make you responsible for having these memorized, but you may want to be familiar with them because especially formic acid and propionic instead of propanoic acid, you'll encounter commonly both on the web and in the literature. It is possible to have two carboxylic acid groups on either end of the parent chain. In that case, we use dioic acid. Just like two alcohols would be diols, in this case we have dioic acids. So this would be pentane dioic acid. There are a number of common names for these dicarboxylic acids, but you're not going to be responsible for remembering the names of these compounds. So let's finish off the video with a couple examples. We want to provide an IUPAC name for the following compound. So generally I like to identify the highest priority group. So I have a bromine and I have alkyl groups. Those don't get any particular priority. The carboxylic acid gets the highest priority. We need to remember that when we're assigning the longest chain, it has to include the highest priority group. So even though I could get 1, 2, 3, 4, 5, 6, 7, 8, that wouldn't include the carboxylic acid. So the best I can do is 1, 2, 3, 4, 5, 6. Of course, I should start numbering it from the end of the carboxylic acid. And so I have 5 bromo. I have a 3 ethyl. And I have a 2 propyl. So putting these in alphabetical order, my name would be again, I don't need to give a 1 for the position of the carboxylic acid because that's understood. And then finally, while I do have a number of chiral centers, since they didn't indicate the stereochemistry in the drawing of the figure, I can't possibly give the RNS configurations. Okay, one last example. So my functional groups, I have an aldehyde, I have a ketone, I have a carboxylic acid. Of course, the carboxylic acid gets the highest priority. My longest chain would be so I have 4 isopropyl, a 5 ethyl, And then whether it's an aldehyde or a ketone, when they don't get priority, they're both substituents. They're oxo-substituents. So I would have a 6, 8 dioxo. So in putting these in alphabetical order, for the final name, I would have 5 ethyl, 4 isopropyl, 6, 8 dioxo. Of course, when we're alphabetizing, I don't use the di. I'm going by the O from the oxo. And then I have 8 carbons. And so then it would be octanoic acid. Again, I want to check and see if there's any stereo designations I need to give. I again have a couple chiral centers, but again, they didn't show the stereochemistry when they drew it, so I don't have to give the RRS configurations.